Hello everyone, this is Shravani. Welcome to Nrcm. I'm going to speak about operating system unit 2. Topics are threads. So first of all, what is a thread? A thread is a path of execution within a process. A process can contain multiple threads. In general, what is process? Process is a program that performs a single thread of execution, as you all know that. And thread is a basic unit of CPU utilization, and this thread also contains a thread ID, a program counter, register set, and a stack. And all these things it shares with another threads belonging to the same process, like the code section, data section, and other operating system resources such as open files and signals. These can be shared. This kind of information can be shared. So if they belong to the same process. Okay, and as we discussed, like thread contains a thread ID. So what is a thread ID? So thread ID is nothing but it is a unique number, and a program counter. Program counter, it stores the next instruction details. And next register set is nothing but it is used for performing some computations. And stack it is used to show some like recursion calls if there are any kind of recursions, function parameters in the program. So, and a process may contain many kinds of threads, but in a traditional process has it was single threaded machine or single threaded process. But if a process has multiple threads, it can perform more than one task at a time, as you all know that. So, and in simple, we can say like thread is also called as a lightweight process, or it is a tiny process. And there are threads are implemented in two ways. One is user level threads, and second one is kernel level threads. User level threads, they are managed by the user, and kernel level threads, they are supported and managed directly by the operating system. So first process, then kernel level threads, and then user level threads. The hierarchy will be like this. And next, coming to the user level threads, like in at the user level threads, the kernel is not aware of these threads, user level threads, and it is not supported by the kernel. Just user level threads are managed by the user level library itself. And user level threads are fast compared to the kernel level threads. And here context switching will happen. So, but the main disadvantage in this user level threads are like if one user level thread performs any of the blocking operation, so then the entire process will be blocked. So this is the main disadvantage of user level threads. Next, coming to the kernel level threads, as we discussed, these kernel level threads, they are managed by the operating system calls. And the kernel level threads, they are slower than the user level threads. And here, as it is slower, and context switching also will be definitely slower. But the main advantage here is that the disadvantage in the like user level threads is a it is advantage in the kernel level thread. Like if one kernel level threads perform blocking operation, the remaining threads will not be affected. So this is the advantage. So, and coming to the different threads as shown in the diagram, we can see the in traditional days, or like in like traditional processes, like there were single threaded process. The process were single threaded process, and nowadays we are using the multi-threaded process. So if you keenly observe this diagram, so this explains, so this is the thread, single thread. So and here we have the different multiple threads. So the thread will be represented in zigzag manner as shown in the diagram. So if you observe here, here for single threaded process, code, data, files, and register stack will be different or individual. So coming to this multi-threaded process, this code data files are common to all the threads, but this registers and stack sets are individual for the different process or for different threads. So this is the main difference. And next we are going with the multi-threading models. There are three types of multi-threading models. So first one is many to one model, second is one to one, and third one is many to many model. We'll see in detail. So first is many to one model. As the diagram itself indicates, like this is many to one, like many user threads. So these all are many user threads. They're mapped with single kernel thread. So here only one thread can access the kernel at a time. Here only one thread can access the kernel at a time. And some examples are like Solaris's GNU portable threads. These are the examples for many to one models. And here the thread management is done by the thread library in the user space. So this many to one model is efficient. But the disadvantage of this many to one model is if any of the thread is blocked, if any of the user thread is blocked, it makes a blocking to the entire system call. So that is the main disadvantage, and no multi-processing is allowed here. Like multi-programming or multi-processing is allowed. So single thread should be mapped with the single kernel. So this is all about many to one model. Next we are going like one to one model. So the diagram itself, in this one to one model, it creates separate kernel thread to handle each and every user thread. Like many different user threads will be there, and these different independent, or you can say individual or independent threads, user threads will be mapped with these different kernel threads. And we can go like examples like one to one model is Windows, NTXP 2000, etc. Linux, Solaris, these all will work on one to one model. So here the advantage is like if one thread is blocked, the other thread can work. It's obviously because if they both are related, if this thread is blocked and the remaining two threads will not be affected and will not be affected. So, and it allows, second advantage will be like it allows multiple threads to run in parallel on processors. So different multiple threads can be running parallelly on the processors as shown in the diagram. And coming to the disadvantage is like it is costlier. I feel it is costlier. Why it is costlier is like creating a user thread requires a creating corresponding kernel thread as we shown in the diagram. So for each user thread there should be the corresponding kernel thread. So because of this, so if there are n number of the user threads and n number of the kernel threads should be mapped individually. So this becomes the disadvantage. And one more main disadvantage is like in one-to-one model, the systems or the operating system, it restricts the number of threads supported by the system. Suppose consider for if the operating system restricts with only 5 threads. So if the processor there, if there are 50 threads to be executed, so each time the 5 threads should be executed. So this comes under the disadvantage of this one-to-one model. So and depending upon the restriction varies from one operating system to the other operating system. So some operating system might restrict, and some operating systems might, the restrictions might be very less, or for some other operating systems the restrictions might be very high. So this is about one-to-one model. So next going on to the many-to-many model. So as shown in the diagram, in many-to-many model, like it allows many user level threads to be mapped to many kernel level threads. Okay, so many user level threads will be mapped to the many kernel level threads. But if you keenly observe here, there are 4 user level threads and 3 kernel level threads. Means that is, it multiplexes many user level threads to a smaller or equal number of the kernel threads. I hope now your doubt is cleared. And coming to the advantages are like user can create any number of the threads, and if you want to if you block any of the like kernel threads or the user threads, so the remaining threads will not be affected. And if the process only will help to split across the process can be split across the multiple processes. Means different processes can be split across the multiple processes. So, and this is all about the many to many model, and in the next video we'll be discussing about the remaining topics. Okay, thank you.